My favorite planet in many ways. Saturn is the most beautiful one to look at in a telescope, as we'll talk about later. But the most interesting one to observe, certainly for me anyway, is Jupiter, because it's always changing. And I spent many, many hundreds of hours, literally, observing Jupiter when I was in my late teens and early 20s, before I discovered women and things like that. And it really is absolutely fascinating. Whole lot of things about it. First of all, it spins on its axis in less than 10 hours. So if you get a good long clear winter's night, you can see the whole planet rotate before your eyes. And this is a thing big enough to hold 1,000 Earths, and yet it spins so incredibly quickly. There's features like the Great Red Spot, which I'm going to talk about, which have been there for probably centuries, big enough to contain several Earths. They're the constant dance of the satellites around it and so on. So it's an absolute delight for anybody that has a reasonable telescope to observe. Things move, things change, things that rotate at different speeds. They get darker, they get lighter, they disappear, new features suddenly appear, and so on. But the Great Red Spot, possibly recorded back in the 17th century. We're not absolutely sure, but it's certainly been there for at least several hundred years. And this thing is humongous. It's basically a gigantic whirlwind in the atmosphere of Jupiter. And as it says on the tin, it's great, and it's also red or sort of pinkish. Sometimes the color varies as well. It can be anything from red to sort of light salmon pink. And it's there, and it's not visible every night, because sometimes it's transiting whenever Jupiter is either below the horizon or in daylight. But if you observe for a couple of nights, you'll definitely see it in any reasonable telescope. And I used to try and measure the size of it in a very primitive way then, but it was the only way available, by timing when the leading edge and the following edge actually crossed the central meridian of Jupiter, the line joining the north and south poles. And back then, it was much more elongated. It was longer in sort of relation to length and diameter than a rugby ball or an American football would be. Now it is shrinking, mainly in length, so it's now more like egg-shaped. So even sort of in the last half century, there have been significant changes in it. And some people have speculated that it's going to disappear altogether. But now, of course, we not only have things like the Hubble Space Telescope, we have had a whole lot of spacecraft going there. And at the moment, Juno, a NASA spacecraft, is in orbit around Jupiter, and it is making detailed observations. And it has found some absolutely fascinating details about the Great Red Spot that we can't really get from Earth. From Earth, we can basically only see the surface of it, but the Juno spacecraft has microwaves that can operate at several different wavelengths, and they can penetrate down right into the red spot and the surrounding area. And they have found that it extends down to probably around 300 miles deep from the surface down into the atmosphere. That's mind-boggling enough. Imagine, if you like, sort of a hurricane on Earth, which is bigger. Well, you can't imagine it on Earth, but it's bigger than the whole Earth, and it's also about 300 miles deep. What's even more fascinating is that the cloud belts surround it. And this thing keeps circulating basically because there are two atmospheric currents, one to the north of it and one to the south of it, and they're traveling at different speeds. So they're sort of making it rotate as they travel around it. Those extend down to a distance of probably about 1,800 miles down into Jupiter. One thing we should bear in mind, of course, is that Jupiter doesn't have a solid surface the way, say, Venus or the Earth or Mars have. It may be solid down in the very core, just due to the extremely high pressure. But there's no solid surface as we understand it. The density of the atmosphere just gets greater and greater as you go down, and then it possibly turns slushy. And then in the very middle, there may be a metallic core. But in terms of the atmosphere, basically it just gets denser and denser as you go down. So we have this huge whirlwind circulating around. So I'm getting a bit of feedback here on my earphones. I'm not sure what it is, but I'll keep going anyway. At least 300 miles deep and being surrounded by other currents in the Jovian atmosphere that go down 1,800 miles deep. Again, these things are just absolutely mind-boggling. Some other things, as it shrinks, it's actually getting slightly taller. So that could be just a redistribution of the mass. It no longer has the same sort of horizontal area. The material that's forming it, whatever it is, different chemicals, probably mainly ammonia, is getting squeezed, so it actually extends up higher into the atmosphere, and that the clouds spinning around the outside are now moving faster than they used to, but the currents near the center of the Great Red Spot are spinning more slowly. And it just shows you the benefits of having a spacecraft there on the spot. We'd never be able to detect that from planet Earth. So an absolutely fascinating object, and the more we find out about it, the more intriguing it is. I'm sure you've enjoyed looking at it many times yourself, Nick.
Oh, absolutely. And I've just posted a link into the chat which shows some of the shrinking of the Great Red Spot, and that's been taken by amateur observers. So again, Terry and I, before we came on air, we were talking about observing Jupiter, and the amateurs in the past maybe 10, 20 years, people like Damien Peach in the UK, Christopher Goh out in the Philippines, Paul Hees in Australia, are doing absolute, and there's so many more now because everybody's getting into very high quality cameras. The quality of the cameras and the high frame rates that they can deliver, and the filters that are now available even to amateur observers, and we're not talking about small investments here, we're talking about several £1,000s worth of telescopes to get images of the kind of quality that you'll see if you do click on that link. But it's now amazing that amateurs are donating so many images to professional scientists. And when Juno wasn't at Jupiter and there was nothing really orbiting Jupiter, getting time on the Hubble to do observations was obviously very tricky. And so a lot of the ground-based telescopes, they're not specifically targeting planetary observations. The big telescopes around the world, they're looking at comets or asteroids or galactic observations, etc. So planetary observations, the amateurs do play a huge role in this, especially when you're looking at consistent monitoring. And you look at the Great Red Spot, the image in that link is a kind of a simulation of that shrinkage that Terry was talking about during this article. But also, Jupiter is 1,000 times the size of the Earth. It could swallow the Earth 1,000 times, and it acts as almost like a gigantic vacuum cleaner for the solar system. And we've got, we talked last time about the missions going out to now look at the Trojan asteroids, which are, orbiting ahead, Trojans and other asteroid groups that are orbiting around Jupiter, which we're trying to get more of a handle on and more information on over the coming decades. And to see that the amateurs are delivering these remarkable images, when we don't have spacecraft, like Juno's there at the moment, but when we don't have spacecraft there, it is incredible because they can also detect things like asteroid and cometary impacts on Jupiter's upper cloud deck. And these have been detected by amateurs on multiple occasions now, where there's an alert network almost where amateurs are saying, look, we think we've got an observation where we're showing an impact on the surface of, the upper cloud decks of Jupiter. It's no actual surface, but the cloud decks. And then the professional observatories will then target that to see if there's any kind of residual aftershock, as it were, if there's any disruption in the cloud layer or any pock holes that you had with, Shoemaker Levy 9 when that hit Jupiter a few decades ago, leave these gigantic scars on the upper cloud decks for several revolutions. But as Terry said, it's fascinating because you can see not only Jupiter itself rotating in a matter of 10 hours, but the moon's orbiting. You can see the shift in position. And this, these are going back to the days of Galileo and some of the first observations of Jupiter with very, very simple telescopes. You don't need anything spectacular to see the moons. A pair of binoculars will do it. And you can see these 4 Galilean moons, Io, Callisto, Ganymede, and Europa. And you think, well, Europa's this ice world that potentially could host life. And Io's this phenomenally volcanic active body, the most volcanically active thing in the entire solar system. And you just got to let your mind wander. So adding to that, these incredible observations from Juno, and I had a lot of a problem with Juno when it first got there because the principal investigator, the lead scientist on it, said it was the greatest thing and it beat the Apollo program. I was like, well, no, it didn't, but it is still a remarkable achievement, the Juno spacecraft, how close it gets and the braking maneuver it had to do to get into orbit around Jupiter so close. So well worth following on, well worth keeping up with what Juno's delivering, because it's almost like the forgotten child of the solar system. We hear a lot from New Horizons still. Alan Stern and his team still doing great science there, and we hear a lot obviously from the Mars rovers and Mars observations, and we're hearing now from Bepi Colombo reaching Mercury, and people tend to almost forget about Juno is orbiting Jupiter, because Jupiter's obviously been orbited previously and flown by on several occasions with the Pioneers and the Voyagers in the 70s.